Welcome to the 19th lecture of digital electronics. So this is the last lecture of module 1. So here we are dealing with enable and inhibit circuits. So what is meant by enabling? Enabling means if an input is there. Enabling means if an input is there, then it is allowed to pass, to the rest part of logic circuit. Whereas what is meant by inhibit? Inhibit means a particular signal or input is not allowed to pass to the other part of logic circuit. That means it is basically switching. Switching means you can enable or inhibit, or it is not exactly the switching. It can be a kind of switching. It is a kind of switching circuit. Okay. Now to perform this enable and inhibit operations, what we have is AND gate, OR gate, NAND gate, as well as NOR gates. These 4 gates can be used for enabling as well as inhibiting. So coming into enable circuits. Okay. So first we will deal with enabling using and OR. Enabling using and, you can use and, NOR, OR, and NOR. That is for enabling. So first you will deal with enabling circuit. So coming into enabling circuit, first one is dealing with AND. How to deal with? You are having 2 inputs, A and B. B is set to 1. Okay, if B is set to 1, what happens? Whatever is the input in A, suppose whatever is the input in A, what is x is equal to A dot B? X is equal to A dot B, and B is set to 1. So that is x is equal to A dot 1. What is A dot 1? That is A itself. You will get the output is always equal to the pulse train which is coming in A. So that means you are enabling the input A to go to any other part of the logic circuit. Okay. Next one is enabling using NAND. Okay. Enabling using NAND. That means if you need to make the complement and enable. So what I am using is I am using a NAND gate. With A as input and B is set to 1. Okay. So what happens? H is equal to A dot B the whole bar. What is it? That is A dot 1 the whole bar. What is it? It is A complement. A dot 1 is A. So we get H is equal to A complement. So if whatever is coming in A, you will get the exact opposite of that. Okay. So this is logic 0. This is logic 0 1. So this becomes this is logic 0 and this becomes logic 1. So the rest part of the logic circuit will be enabled according to the complement of A. So that is enabling. Now coming into enabling using OR logic. So you are having A and B is set to 0. When B is set to 0, what happens? You will get H is equal to A or B. And B is 0. What do we get? A or 0. What is A or 0? That is A itself. That means if you are having some pulse train A, you will get the same value as H. Okay. So that is basically that is you are enabling the signal coming in A to pass through the rest part of a logic circuit which is having S as input. Next one is enabling using NOR. So here NAND is there. Next is enabling using NOR. So here again I am having a NOR gate. A is there and B is set to 0. So what is here? X is equal to A or B bar. But B is equal to 0. So what will you get? You will get just A or 0 the whole bar. What is A or 0? A or 0 is A itself. So you will get complementation of A. So if I am giving a signal like this to A, you will get X at ulta of that signal. Okay. So here you will get X is equal to A bar. That means you will get the combined part as input to the other part of logic circuit. Okay. So this is the enable circuit based on AND, NAND, OR, and NOR. Now coming into inhibit circuits. Inhibit means inhibit circuit. Inhibit means you have to stop whatever is coming in the input going to the next part of the logic circuit. Okay. So inhibit can be again used again performed using AND, NAND, OR, and NOR. First one I will explain about inhibit using AND gate. Okay. So I am having an AND gate. A is there. B. Here what happens is that B is set to 0. That means one input is set to 0. That means here you get X is equal to A dot B. But B is equal to 0. So what do you get? A dot 0. So what do you get? That is 0. So whatever is coming in the input of A, in the output S, you will always get 0. That means whatever signal is in A, it is not allowed to pass through the first part of the logic circuit. Now coming into NAND gate, how NAND gates act as inhibit circuit. You are having a NAND gate. So here you are having A. B is set to 0. So here we get X is equal to A dot B the whole bar. You get A dot B the whole bar. What is it? That is A dot 0 the whole bar. What is it? A dot 0 is 0. 0 bar is 1. That means whatever is coming in A, only logic 1 goes as X. Okay, so that is X is here. This is only 0 and logic 1. Only logic 1 goes as X. That means the exact pattern of A is inhibited to go into the rest part of the circuit. That is the inhibit using NAND gate. Next one is inhibit using OR gate. Inhibit using OR gate. That means here what we get? Having OR gate A and B is set to 1. So here what we get? X is equal to A or B. What is it? That is equal to A or 1. So something or 1 is always 1. That means X remains as 1. So whatever is coming in A, the output will be always in logic 1 state. Therefore what you can see, whatever is coming in A, it is not allowed to go to the rest part of the circuit. That means that is made to logic 1. Okay. So inhibit using NAND gate as well as inhibit using OR gate is exactly the same operation. Now coming into inhibit using NOR gate. Inhibit using NOR gate. So here I am using a NOR gate. I am using a NOR gate. So we get A and B. Here B is set to 1. So what is X? X is A or B the whole bar. But B is 1. So it is A or 1 the whole bar. What is A or 1? It is 1 only, 1 bar. 1 bar is 0. That means whatever is coming in A, the output of X will be always logic. So it will be a straight line which is in it will be a line which is only in logic 0. This is logic 1. This is that. Okay. That means here what happens is that in NOR gate, using NOR gate also you can inhibit provided the other input is remaining as 1. So we have understood the concept of enable and inhibit. Enable means the input is allowed to pass through the rest part of the circuit either in the same form or in the complemented form. Then inhibit means you are not allowing the signal to pass in the signal coming in to pass through the rest part of the logic circuit. That means that to the rest part of the logic circuit the input coming will be in logic 0 or logic 1 only. So with that I am ending with the lecture on module 1. So module 1 we have 19 lectures. So in module 1 it is only up to inhibit circuit, and the rest part of module 1, that is TTL, NAND gate and CMOS NOR gate, we will deal in the last part of the subject. Thank you.